Hi, and welcome to our new unit, Unit 8, Transformations. Today, we're going to look at an introduction to transformations and talk about translations. Some important vocabulary that we need to begin with are the words pre-image, image, and isometry. Your pre-image is your figure before you've done a transformation. So before you've slid something, rotated something, reflected something, dilated something. That's your pre-image before you've done anything to it. Your image is your figure after you've translated it, reflected it, rotated. Okay? An isometry is a transformation that preserves size and shape. So once you've done your transformation to your figure, it's still going to be the same size. It won't have gotten bigger or smaller. And it's still going to be the same shape, meaning it won't stretch out or squish in. Okay? So when I look at my examples, it says, are the following isometries? So here I can see I have this small quadrilateral that looks square-like and a larger one. So because they have different sizes, we have to say, no, this is not an isometry because they are different sizes. Okay? My next one, I have my pre-image here and my image here. I know that's really tiny to see, but I can see that it looks like they are the same size. They're the same shape. One's just been either rotated around or reflected over to the other side. Okay, so this one we're going to say yes is an isometry. And then the last one, I have these two triangles here, and again it appears as though those two triangles are the same size and the same shape. One's just been flipped over. So we're going to say yes, these are isometries. So again, an isometry preserves size and preserves the shape. When we look at transformed images, they're going to have corresponding parts from the first shape to the second shape. So for example, this bottom piece here will correspond to this bottom point here. This outside point here will correspond to this outside point here. This top point here will correspond to this top point here. And same thing with my sides, right? This segment here would correspond with its matching piece over here. Okay? So the corresponding parts are going to get named. And when we name them, we are careful to use correct notation. We're going to be using what's called prime notation, and the prime is notated with a little apostrophe. Anytime you see the apostrophe, you know that is a figure that has been changed from the original. It's the image, not the pre-image. So we use this apostrophe as notation to indicate that a transformation has happened, and when we see something that looks like this, when we read it out loud, we read it as A prime. Okay? So for example, if I take triangle JKQ and I slide it over to the right, so now I have 3 new points of this new triangle. I'm not sure why there's a little gap there. Pretend that's closed. Then I would have the new point J prime, the new point K prime, and the new point Q prime. And my new triangle would be triangle J prime, K prime, and Q prime. Okay? The corresponding angles would line up just like you would expect them to. So my angle J is going to be corresponding to angle J prime. Angle K is going to correspond to angle K prime. And angle Q is going to correspond to angle Q prime. Same thing with my sides. Segment JK is going to correspond to segment J prime, K prime. Segment QK is going to correspond to segment K prime, Q prime. And segment JQ is going to correspond to segment J prime, Q prime. Okay? So that's what you need to know about general transformations, just transformations in general. So now we're going to talk about specifically a translation. And you've probably talked about it before. And in middle school or elementary school, when you talked about translations, your teacher probably said that you can remember what a slant translation is by remembering the key word slide. Because a translation is just sliding a figure. It moves all the points of the pre-image the same distance in the same direction. So A to A prime, B to B prime, and C to C prime are all moved the exact same direction and distance. So you're going to end up with a shape from your pre-image to your image. Your image will be the exact same size and shape as the pre-image. So if I were to ask, is a translation an isometry, we would say yes. Translations are isometries, because we're not going to be changing the size or the shape of our figure. Okay? In the next video, we're going to look at identifying pre-images and images, and we're going to discuss how to use coordinate notation when we have figures graphed on a coordinate plane. All right? So come on back so we can continue with translations. Thanks for watching.